Okay, now we start with the reaction turbine. If we see the impulse turbine, the variation in pressure velocity diagram in previous video. Now let's start with the video recording on the reaction turbine. Okay, if you take the cross section area of the reaction turbine, previously I told that in case of impulse, okay, if you cut that blades, okay, and if you cut the blades of the reaction turbine, what we observe change here in impulse turbine, the cross section area between two blades is the same. Cross section area is same. But if we see in case of the reaction turbine, the cross section area is varying. Varying cross section is case of reaction turbine is very important. Okay, while I'm developing or the design in case of reaction turbine, I the nozzle is replaced with fixed blade of reaction turbine. Is very important. Note down. In case of reaction turbine, the nozzle is replaced with fixed blade of reaction turbine. So developing the reaction turbine, okay, if you see the impulse turbine, the whole pressure drop is takes place in a nozzle. But in case of reaction turbine, there is no, I am going to replace the nozzle. The role of nozzle is done by the fixed blade of reaction turbine. And that fixed blade is placed in casing of that turbine. If you see the turbine body, the outer casing, okay, in that outer casing, so I have placed the blades of the reaction turbine which act as a nozzle, and the moving blade I am going to place on the rotor. So if you see here the construction like the reaction turbine, okay, there are different kinds of nozzle. Okay, if you see here the blades and the nozzle, okay, if you see this row, there are two rows. Okay, in case of see this, if you see the row of nozzle here, and if you see the row of blade here, okay, and when I cut this section, if you see this is the front view of, if you see this from this side view, okay, if we see this is the blade, this is a set of nozzle. Actually this is a set of nozzle which is followed by set of blade. Okay, now we draw the reaction turbine and their pressure velocity diagram. Okay, the only change I told that there is a varying cross section and a nozzle is replaced with fixed blade. So it consists of one set of fixed blade which is followed by set of moving blade. Okay, this is single stage, and another stage the same. Okay, so in case of reaction turbine, I use the word fixed blade, moving blade, fixed blade, moving blade. This is the stage 1. So it consists of two set of moving blade which is followed by set of fixed blade. And I have told that already in case of reaction turbine, nozzle is replaced with the fixed blade, and the cross sectional area, if you see the cross sectional area between two blade is varying. So in the exam it is necessary to draw the at least 5 to 6 blades. Okay, and the set of moving blade, if we see the arrangement, okay, if we see the set the blades in that direction, okay, so moving blades are placed in that opposite direction. Similarly, you have to draw for the again fixed blade. I'm just going to draw sample few blades. Okay, in at least exam you have to draw 8 to 9 blades. In case of moving blades, the installation of the blades in opposite direction of that fixed blades, so the steam can easily flow over them. Okay, this is a single stage of the reaction turbine. Now you draw here the pressure velocity diagram, the variation in a pressure velocity diagram. You know that the steam is coming from the boiler at high pressure, so here the pressure. So first we discuss about the pressure, okay, then we discuss about the velocity. So I am going to first discuss the pressure parameter. Okay, when the superheated steam coming from the boiler at high pressure, okay, when it flows through the fixed blade, the steam, when the steam is flowing through that fixed blade, okay, I told that the fixed blade is act as a nozzle. So when we know the function of the nozzle here, now there is a drop in a pressure. Okay, now when that drop in a pressure, okay, when that steam again flowing through the moving blade, in case of impulse turbine there is a pressure is a constant because there is a cross sectional area between blade is a same. But here in case of reaction, the cross sectional area between blade is varying, so the again drop in a pressure. Okay, now again steam flows over the fixed blade, it acts as again nozzle. We know the nozzle, the function of nozzle, there is a drop in a pressure, correct? When again steam flows to the last set of fixed moving blade, there is again varying cross section, there is again drop in a pressure, and that is the outlet pressure. Now what about velocity? I'm just changing this ink color so we can easily identify the variation. When the steam superheated steam at high pressure coming through that fixed blade is act as a nozzle, there's a drop in a pressure and increasing its velocity. Okay, when that high velocity of steam strike on the moving blade, we know that when it strike on the moving blade, then and there is a drop in a velocity. Okay, again that steam flowing over the fixed blade, it act as a nozzle. So in nozzle there's drop in a pressure and increase in velocity. Okay, that high kinetic steam again moving through the moving blade, there is a drop in its kinetic energy, and this is the outlet velocity. So if we compare with this impulse turbine, if you see in impulse turbine, there is a in nozzle there is a drop in a pressure and increasing its velocity is okay. But when it's flowing through the moving blade, always remember when the steam is flowing over the moving blade, there is a drop in kinetic energy. There is drop in kinetic energy. But in case of impulse, pressure is a constant because cross sectional area is same. But if you compare with the reaction, when the steam flowing over the moving blade, also there is a drop in a pressure because the cross sectional area between blade is varying. But as with compared to impulse, the pressure is a constant in impulse, but in reaction the pressure is also going to decrease or drop in a pressure because varying cross section. So the word varying cross section area between blade is very important. So I again conclude that in case of moving blade, any moving blade, there is a drop in velocity. Okay, drop in velocity, but that moving blade cross sectional area is the same, pressure is a constant. Okay, and that moving blade cross sectional area is varying, pressure is decreases. So we remember this fact is very important. Okay, and in case of nozzle, we know the nozzle, the role of nozzle, there is a drop in a pressure and increasing its velocity. And the reaction blade, the fixed blade of the reaction turbine is act as a nozzle, So this is a very important key points of this video. Okay, the cross sectional area, this is our reaction turbine. So if we see the reaction turbine, what is the change or what is the difference between, now we discuss the difference between the impulse and the reaction turbine. I told that in impulse turbine the whole pressure drop. In case of impulse turbine, the whole pressure drop in nozzle only. Okay, but in case of reaction turbine, the pressure drop takes place over all the stages. This is very important. So I think hopes you understood the impulse and the reaction turbine.